Hello students, in the previous two videos on vectors, I explained the introduction for the vectors and various types of vectors, representation of vectors, addition of vectors, laws of vector addition are discussed in the first video, and in second video parallelogram law of vector addition was explained. So please watch that two videos before you watch this third video. So today I am going to explain the applications or special cases on parallelogram law of vector addition. So in second video I explained the parallelogram law of vector addition. According to the parallelogram law of vector addition, we know that magnitude of resultant vector of two vectors is capital R is equal to square root of p square plus q square plus 2pq cos theta, where R is the magnitude of resultant vector, P magnitude of P vector, Q is magnitude of Q bar, and theta is the angle between P bar and Q bar. Angle between P bar comma Q bar. And to know the direction of resultant vector, we have a formula alpha is equal to tan inverse of q sin theta divided by p plus q cos theta. These two formulas I explained in the second video. Now first case, if p bar is parallel to q bar, P bar is parallel to Q bar, that is angle between P bar and Q bar is equal to 0. Then what happens the resultant and as well as direction of resultant, magnitude of resultant and direction of resultant, R and alpha. See, let us take P bar and Q bar. P bar and Q bar are acting in the same direction. P bar is a vector and Q bar is another vector. According to the magnitude formula, you can write R is equal to square root of P square plus Q square plus 2pq cos 0 degrees. We know that cos 0 is equal to 1. So that implies R is equal to square root of P square plus Q square plus 2pq into 1, or that is equal to square root of P plus Q whole square. P plus Q whole square, square root cancel, that implies magnitude of resultant of P bar and Q bar is magnitude of P bar plus magnitude of Q bar. This is resultant. So that now we can draw, this is P vector, Q vector, and R bar is resultant. So this is P bar and Q bar second vector. So R bar is equal to P bar plus Q bar. And direction of resultant. To know the direction, we should find out alpha value. Alpha is equal to tan inverse of Q sin 0 degrees divided by P plus Q cos 0 degrees. So that implies alpha is equal to tan inverse of we know that sine 0 is equal to 0. 0 by anything is equal to 0. So tan 0, or that implies alpha is equal to 0, because tan alpha is equal to 0. So it means R bar is parallel to either P bar or Q bar. This alpha is the angle between R bar and P bar as per our parallelogram law of vector addition discussion in the second video. Alpha is the angle made by resultant vector with P bar, so that R bar is acting in the direction of P bar. Next, second point. If P bar is anti-parallel to Q bar, P bar is anti-parallel to Q bar, that is theta is equal to 180 degrees. Angle between P bar and Q bar is 180 degrees. Then what happens? The magnitude of resultant and direction of resultant. From magnitude of resultant formula, R bar is equal to P square plus Q square plus 2PQ cos 180 degrees. We know that cos 180 degrees is equal to -1. So therefore, capital R is equal to square root of P square plus Q square plus 2PQ into -1, or capital R is equal to square root of P square plus Q square minus 2PQ. This can be written as P minus Q whole square. Square root cancel. That implies magnitude of resultant of two vectors is equal to P minus Q. P minus Q. P magnitude of P bar, Q magnitude of Q bar. And next, direction. To know the direction, we know that alpha is equal to tan inverse of Q sin 180 divided by P plus Q cos 180 degrees. But sin 180 is equal to 0. So here also tan inverse of 0, because numerator 0, or tan alpha is equal to 0. Therefore, alpha is equal to 0. Alpha is equal to 0 means resultant of two opposite vectors is parallel to first vector, because alpha is angle between resultant and, so that now we can write here. See here, let us take P bar. This is this straight line represents P bar and Q bar. P bar and say let us take Q bar. This is Q bar. Q bar vector. Then let us assume that P bar and Q bar. Now R bar is, so this dotted line gives R bar. So that is R modulus of R bar is equal to modulus of P bar minus modulus of Q bar, and alpha is equal to 0 means P bar is parallel to R bar, or R bar is parallel to P bar. Next, third point. If P bar is perpendicular to Q bar, P bar is perpendicular to Q bar, that is theta is equal to 90 degrees, then what happens? The magnitude of resultant and angle made by the resultant with P bar. Let us take here P vector and Q vector are mutually perpendicular to each other. This is P vector and Q vector. Angle between P and Q is 90 degrees. From R is equal to square root of P square plus Q square plus 2PQ cos theta, square root of P square plus q square plus 2pq cos 90. We know that cos 90 is equal to 0. So therefore, r is equal to square root of p square plus q square only. This is the magnitude of resultant of two mutually perpendicular vectors. And to know the direction, from alpha formula, alpha is equal to tan inverse of q sin 90 divided by p plus q cos 90. Sin 90 1, cos 90 0. So that this can be written as tan inverse of q divided by p. So that implies alpha can be written as tan inverse of q by p. This alpha gives the direction of resultant vector. Let's take here this is r bar. R bar, and angle between r bar and p bar is alpha. Angle between r bar and p bar is alpha. Suppose here magnitudes of p vector, and if modulus of p bar is equal to modulus of q bar, or if p is equal to q, then r is equal to square root of p square plus q square, or q square plus q square, anything. So that is equal to square root of 2p square, or r is equal to root 2p. This is the resultant, and alpha, angle made by resultant with p bar, alpha is equal to tan inverse of either q by q or p by p. So cancel, that is equal to tan inverse of 1. So that implies alpha is equal to tan inverse of tan 45. 1 can be written as tan 45. So tan cancel. That implies angle made by the resultant with first vector is equal to 45 degrees. Exactly 45 degrees if two vectors magnitudes are equal. Next, fourth one. If modulus of p bar is equal to modulus of q bar is equal to modulus of r bar, then see here, magnitude of p vector, magnitude of q vector, and the resultant vector r bar magnitudes are equal. Then that is p is equal to q is equal to r. Then see, from r is equal to square root of p square plus q square plus 2pq cos theta. Let us now take all the three values are same, either p or q or r. I can take first of all here p square plus p square plus 2p square cos theta. Can keep r also, we can take either p or q, but we can keep r up to some certain time. Then r is equal to square root of p square plus p square, 2p square plus 2p square cos theta. So that is r is equal to square root of 2p square is taken as common. So 1 plus cos theta. 2p square into 1 plus cos theta. So we know that 1 plus cos theta, we have three formulas for 1 plus cos theta. Here I am taking 2 cos square theta by 2. 1 plus cos theta is equal to 2 cos square theta by 2. Two more formulas are also there. Therefore, r is equal to square root of 2p square into 2 cos square theta by 2. That implies r is equal to square root of 2 into 2 2 square p square cos square theta by 2. All squares square root cancel. So that implies r is equal to 2p cos theta by 2. This is resultant of two equal vectors. Resultant of two equal vectors. If r is equal to p, if r is equal to p, then see p is equal to 2p cos theta by 2. P cancel both sides. So that implies cos theta by 2 is equal to 1 by 2. So 1 by 2 can be written as cos 60 degrees. Cos 60 degrees is equal to 1 by 2. So both sides cos cancel. So that implies theta by 2 is equal to 60 degrees or theta is equal to 120 degrees. If p bar modulus of p bar is equal to modulus of q bar is equal to modulus of r bar, then angle between p bar and q bar is 120 degrees. Or from general formula r is equal to 2p cos theta by 2, then from alpha, this is a special case. If r is equal to p is equal to q, from alpha tan inverse of p sin theta divided by p plus p cos theta. In the place of q also, now I am writing p. So that is equal to tan inverse of p sin theta numerator divided by denominator p is taken as common. So 1 plus cos theta. 1 plus cos theta. P gets cancelled in numerator as well as in denominator. So alpha is equal to tan inverse of sin theta divided by 1 plus cos theta. I gave already in the above 1 plus cos theta is equal to 2 cos square theta by 2. And sin theta formula also we have in trigonometry in mathematics. So sin theta can be written as 2 sin theta by 2 cos theta by 2. So these formulas you will learn in your mathematics, trigonometry. And 1 plus cos theta I gave already in the previous slide. So that implies alpha is equal to tan inverse of sin theta now. So 2 sin theta by 2 cos theta by 2 divided by 2 cos square theta by 2. So here 2 cancel, 1 cos theta by 2 cancel. So that implies alpha is equal to tan inverse of sin theta by 2 divided by cos theta by 2. Sin theta by 2 divided by cos theta by 2 is tan theta by 2. So tan inverse cancel, so that alpha is equal to theta divided by 2. When magnitudes of p bar is equal to magnitude of r bar, or magnitude of p bar is equal to magnitude of q bar. If two equal vectors, resultant of two equal vectors can be written as 2p cos theta by 2. Direction of resultant vector makes an angle theta by 2. So for this, suppose if theta is equal to 60 degrees, if p bar and q bar are inclined at 60 degrees, then r is equal to 2p cos 60 by 2, that is equal to 2p cos 30. Cos 30 is equal to root 3 by 2. So 2p into root 3 by 2. 2 cancel, so root 3p. That implies r is equal to root 3p. R is equal to root 3p and alpha is equal to 60 by 2. that is equal to 30 degrees. Suppose if angle between P bar and Q bar, angle between P bar and Q bar is 90 degrees. 90 degrees. Two equal vectors are inclined at 90 degrees, mutually perpendicular. Then R is equal to 2P cos 45 degrees. 90 by 2, that is equal to 2P into 1 by root 2, that is equal to root 2P. So 2 can be written as root 2 into root 2. 1 root 2 cancel in numerator and denominator. So root 2P. And alpha is equal to 90 by 2. 90 by 2, that is equal to 45 degrees. I explained already this second one. Next, if theta is equal to 120 degrees, this also explained as a special case. So R is equal to 2P cos 60, 120 by 2. Cos 60 is equal to 1 by 2. 1 by 2, so that P, R is equal to P. This point also explained already. And alpha is equal to 120 divided by 2, that is equal to 60 degrees. Resultant makes an angle 60 degrees with either of the two vectors. Next, fourth one. If theta is equal to 180 degrees, then R is equal to 2P cos 90. R is equal to 2P 180 by 2. 180 by 2 is equal to 90. Cos 90 is equal to 0. Cos 90 is because this is I explained as second point. P minus Q. R is equal to P minus Q. If they are equal and opposite means cancelled. R is equal to 0. R is equal to 0 and alpha is equal to 180 divided by 2, that is equal to 90 degrees. And next point, fifth point. If R is perpendicular to P, R bar is perpendicular to P bar, R bar is perpendicular to P bar, then see, resultant of two vectors is perpendicular to first vector or perpendicular to any one vector. So then angle between the two vectors becomes more than 90. So let us assume it is Q bar. This angle between these two is 90 plus phi, that is equal to theta. From alpha is equal to tan inverse of Q sin theta divided by P plus Q cos theta, or tan you can write left side. So tan alpha is equal to Q sin theta divided by P plus Q cos theta. If alpha is equal to 90 degrees, then tan 90 is equal to infinity. So to get infinity, right side denominator must be equal to 0. So to get infinity, so P plus Q cos theta must be equal to 0, or Q cos theta is equal to minus P, or cos theta is equal to minus P divided by Q. Cos theta is equal to minus P by Q. Cos theta is negative. Cos theta negative means it is in second quadrant. That is theta is greater than 90, or 90 degrees between theta lies between 90 and 180 degrees. 90 and 180 degrees. So in the above diagram, let us take here sin phi, cos phi, tan phi also we can write here. From from figure, sin phi is equal to, observe the diagram here, sin phi is equal to opposite. Opposite is p bar, opposite to sin p bar, this is p bar opposite, opposite by hypotenuse, that is p by q. Sin phi is equal to p by q or modulus of p bar by modulus of q bar, and cos phi is equal to adjacent by hypotenuse, tan phi, sin phi by cos phi, sin phi by cos phi or opposite by adjacent, p by r. Tan phi is equal to p divided by r, where theta is equal to 90 plus phi, 90 plus phi. Okay students, thank you. In the next video, I will explain triangula of vector addition, and polygon law of vector addition and Lami's theorem, resolution of vectors, and subtraction first of all. Fourth one is resolution of vectors, and lastly fifth one is subtraction of vectors. These 5 topics I will explain in the next video, that is fourth video. Okay students, thank you, bye.